Dear friends, I myself, Dr. Bharat Parab, discussing quadrilaterals. Presently, we are discussing polygon properties. So to study quadrilaterals, we need to study some definitions. Here are some definitions. Presently, polygon, a simple closed curve made up of only line segments, is called as polygon. That means you do not have curve. Okay. So polygons are classified by the number of sides it contains. See here, number of sides or vertices 3, then triangle, then this is a figure. Then 4 is quadrilateral and this is a figure, 4 sides. 5 is pentagon and this is a 5-sided figure. Okay, like that 6 hexagon, 7 heptagon, 8 octagon, like that n-gon is number of sides n. So many number of sides. Okay, so this is a definition of polygon and its classes. Okay, second definition, diagonal, a line segment connecting two non-consecutive vertices of a polygon, that is the diagonal. What does this mean? This means, see here, this is a diagonal, this is a diagonal. What do you mean by consecutive? Consecutive means just near to any point. These and these 2 points are consecutive. So if you take another point consecutive to this, then this and this are consecutive, but these are non consecutive. This there is a point in between. So if you connect this, any one of these, okay, then this is the diagonal. See here, it will be clear from here. These and these are non consecutive. So this is the diagonal. This is the diagonal. Okay, this is the diagonal. This is the diagonal. That means red lines are diagonals. So you know what is diagonal. Okay. From this we move ahead to find what is convex and concave polygons. Okay, see these figures and these figures, these are having some different shapes. So difference between these two, how you will explain in a proper mathematical language, is diagonals are totally inside the polygon. Okay, these are called convex polygon. You see here, if you draw any diagonal, they fall totally inside this figure, and in this case diagonals are not totally inside the polygon. These are called concave polygons. Okay, now see here, this is the diagonal, this is the diagonal, a whole diagonal falls outside the main figure, or even a part of it falls outside. If you join this and this, a part of a diagonal will fall outside the figure. Okay, so that is also not a convex, which is a concave. Okay, so this is the difference between convex and concave. We will be studying only convex, and this is just to understand the difference. Okay, another very interesting and important definition, or definitions rather, regular and irregular polygons. Okay, see the difference. Polygons which are equiangular and equilateral are regular polygons. Means angular means all angles are equal. Okay, not only angles, even sides are equal. Okay, this is equilateral angle. When angles, all angles are equal and all sides are equal, are called regular polygons. Each figure has a segment of equal length and angles of equal measures. Okay, and these are represented as this, and a single line representing this, or double line like this. So this is all about a regular polygon. Okay, we need to study this. And what are irregular polygons? That not all, but at least, if at least one angle or one side is not equal to the other, then also it cannot be called as a regular, but it will be called as irregular polygon. In this case, the angles are equal 90, all 90, but this side and these sides are not equal. Okay, here this side is not equal to this side, is not equal to this side, and angle this is not equal to this and this. So these figures, each figure has a segment of different length and measures of angles are different. These are called the irregular polygons. Remember this difference properly. Okay, it's very easy. So after having studied the definitions, we are now moving to the properties. Okay, first angle sum properties is interior and exterior angle properties. Okay, we are talking about the sum of the angles, sum of the angle measures of the angles. Okay, so polygons carry certain properties related to the interior angles, exterior angles, and diagonals. Okay, so we will tackle interior angle first. Sum of the interior angles. See, we are only concentrating on sum of the interior angles. Okay. Now let us study this calculations of these figures. Okay. This is a triangle. This is a four-sided quadrilateral. This is a polygon having 5 sides. This is having 6 sides. So I am representing here 3 sides, 4 sides, 5 sides, 6 sides. Okay, and you see this is a triangle. So sum of this is 180. Sum of the angle is 180. So angle sum is 1 into 180. How many triangles? 1 into 180. Okay. So if you draw this line, this will be divided into two triangles. So 2 into 180 is 360. Very easy. We can divide this into three triangles. Okay. So 3 into 180 is the sum of the angles of this. Then for this, it's 4 into 180. So number of triangles into 180. That is the equation related to this sum of the angles. So there is a common relation or common formula to find this. Okay, this is the relation. If you take this 3 minus 2, okay, if you take number of sides and subtract 2, multiply by 180, you get this. 4 minus 2, always this 2 is constant, and take the number of sides minus 2 into 180, the sum of the angles of interior angles. Okay, 5 minus 2 into 180, 6 minus 2 into 180. So in general, the sum of the interior angles of polygon is given by the relation angle sum is n minus 2 into 180, where n is the number of sides of the polygon. Okay, it's very easy to remember, and if you are asked to find out the interior angle measure sum, then you can find by this. Okay, angle sum properties, exterior angles property. Okay, the sum of the measures of exterior angles. See here, this is a property, sum of the measures of exterior angles of any polygon is 360. Take any sided polygon, always the sum of the exterior angles, okay, is 360. You know what is exterior angle. Okay. Hence, with this, the relation between the exterior angle and sides of a regular polygon, see we are talking about the regular polygon, you know what is regular polygon, is 360 divided by n equal to a, where n is the number of sides and a measure of one exterior angle. Okay, To understand this, I am taking a example here. Find the number of sides of regular polygon. We are talking about only regular polygon whose each angle is 45. Here answer, here we are given A, this is given, we have to find N, we have to find the number of sides N. So 360 upon N equal to 45. So you cross multiply it like this and you get N equal to 8. So the polygon has 8 sides. Very simple. Try to understand this, and this will be very easy for you. Okay. After angle property, we are moving to the diagonals of a polygon property. Okay. Look at these figures. It's very easy. It's very simple. This is a triangle, three-sided. This is four-sided. This is five-sided, and this is six-sided. Okay. We try to draw the diagonal. This has no diagonal. This has two. This five-sided has five diagonals. All these are diagonals. Six-sided, all these are diagonals. Look at it. Okay. So we try to find the relation between the number of sides and number of diagonals. See here, it is 0, it is 2 here, it is 5 here, and 9 here. And this is the relation between the number of sides and number of diagonals. The number of diagonals equal to n into n minus 3 divided by 2. This is the relation. Okay. Where n is the number of sides of polygon. And we'll try to solve this. We're trying to get a number of diagonals of this six-sided figure. 6 into 6 minus 3 divided by 2. If you try this, this is 3, this is divided by 3, 3 into 3 is 9. Okay. So this is the relation. Try to by it. If you ask to find out the number of diagonals, you can use this. Okay. So after this, let us solve some examples on this topic and presently find x in all the cases. Okay. So we move ahead. Find x. Always study that figure which is given in your question paper and copy it in the answer book and write all the necessary measurements or whatever data given. The rough figure you have to always draw. That will make your problem easy, and have that practice. So I have drawn this. Okay, very slowly. You need not go to the exact measurements, but approximately. Okay. Now this is 50. We are writing angles. This is 50, and this is 130. Now this is 120, and the remaining angle is x, which we have to find out. Okay. Which property you are going to use? That all these angles are in, of course, degree, degree radians. So we are going to use the property sum of the interior angles of the quadrilateral is 360. Okay. So now the problem is very simple. Okay. We will be dealing with such type of problem or little difficult problem ahead. So let us concentrate on this first. So as interior angle addition is 360, so we have 50 plus 130 plus 120 plus x is equal to 360. Very simple. So add this. I think it is 300 plus x equal to, I add this, 300 plus x is equal to 360. Yes, that means x is equal to 360 minus 300 is 60 degrees. Don't forget to write the unit. Okay. So that's the answer. Have some practice. Okay. Answer, and don't write the answer like this. Okay. See you. Find x, where x is a internal angle of a quadrilateral. See how the quadrilateral is given. Draw the rough sketch of quadrilateral on your paper. That is, you have to copy it from the question paper and then mark the angles, whatever data given on the figure, and this is 60, that is 70. Okay, this is 90 as the angle before that or beside that is 90, so this is 90 and this is x. Okay, now what property you are going to use? See, given a property, we use a angle sum property. Internal angle of a quadrilateral and the sum of the internal angles, angle measures of the internal angles of a quadrilateral, okay, is equal to 360. Okay, is okay, going slow for you to understand it properly. Okay, so we write it 90 plus 70 plus 60 plus x is equal to 360. I am deliberately writing x at the end. You may take your own way. You can write clockwise or anti-clockwise, whatever it may be. Okay, but ultimate answer you have to do the calculation, proper calculations. So 220 plus x equal to 360. So x equal to 360 minus 220 is equal to 140. Okay, so that's the answer. Don't forget to write the units, that is degree. Okay, we have to find x. What is this x? X is an angle in some figure. Okay, unknown angle. So we have to study this figure first. So we will redraw it on or copy it from question paper on the answer sheet. Just approximate measurements, not to the scale, and by pen only, so that we can write all that data or whatever necessary. If measurements are given, we can write it. Now this is 60, now that is 70, that is 30. All these angles are in degree radians. Okay, so we have to note that. Okay, that we have we cannot neglect the units. Okay, always that is very important. Okay. As the 70 is on a straight line and the outer angle of that is 70, that means inner angle is this angle is 180 minus 70, and that will be 110, and this angle is 180 minus 60, that is 120. Now which property of the angle you are going to use for this? See, there is a formula for sum of the internal angles of a polygon. Polygon means having many sides. Okay, we are dealing with 5 sides. This is pentagon. Okay, this is a particular figure of pentagon. Okay, but otherwise we are writing the formula for polygon so that you can use it anywhere anytime you want. Okay, so this is a formula given, just read it. Above figure is a pentagon. Okay, my angle sum rule, that the sum of the interior angles, see we are talking about the sum of the interior angles of polygon. Okay, any means any number of sides is equal to n minus 2 into 180. What is this n? N is a number of sides. Now in this case it is 5. Okay, you can use this formula for other problems to get answer. Okay, so we will solve this by substituting 5 instead of n in place of n. So 5 minus 2 into 180 is 3 into 180 is 540. So the sum of the angle of this particular figure is 540. Now it is very easy. You have to just substitute. Okay, one of the angle is 30, then plus 2x, then 110 and 120. This is all 540. Okay, now it is just some arithmetic calculation, very simple calculations. Now we have to add 2x equal to, we have to add the whole thing, that is I think 260. Okay, so 2x equal to 540 minus 260 is I think 280. 0 and 4, yes, it is 280. Okay, that means x equal to 280 divided by 2 is 140. Very simple. Okay, so have some practice, write this answer. Okay, x equal to 140 degree. Okay, good luck. Find x where x is the angle of a pentagon. So we will draw a rough sketch of pentagon where all sides are equal. We will just draw it by pen only, not to scale, just to understand it. Okay, 5 sides, pentagon means 5 sides, and this x you have to find out. This is that x. Now by rule it says that if all the sides of the pentagon are equal, that means all the angles are equal. Okay, so that is a rule we have to follow. So that gives us one equation, okay, of x, that all of them are equal. Okay, now another rule is the sum of the interior angles of pentagon or any polygon, okay, any sides, is equal to, see, we have seen this many times in many problems or in theory, that is equal to n minus 2 into 180. Sum of, you see, writing it here, remember this formula correctly and you will not make any mistake. Okay, so this is for pentagon, irrespective of the sides are equal or not. Sides are equal and angles are equal is another property. For any pentagon, okay, or any polygon, the sum of the interior angle is given by this formula, n minus 2 into 180, where n is equal to 5 in this case. Okay, so we solve it. 5 minus 2 into 180 is 3 into 180 is 540. Okay, so interior angle sum is 540 and all angles are equal. There are 5 angles. Very simple. That means phi is equal to 5x equal to 540. Okay, so x equal to 540 divided by 5 is 10, I think it is 108. Okay, 108. That's the answer. Always do write a unit, in this case degree, for angles. Okay, find x in this figure, in the following figure, where x is an exterior angle in that figure. Let us look at it. This is a figure. Always draw some rough figure from the question paper on your answer sheet or in notebook, and then write this data which is given there and what is asked, everything. Okay, now try to apply the property or the rule which is relevant to this. Here the by the sum of the measures of exterior angles of a polygon, okay, we are applying that property. Okay, sum of the exterior angles of polygon. In this case, it's just a triangle, so the property remains same. So we will see, which says that what is that property? The sum of the exterior angles of the polygon is 360. Remember that. Okay, always these properties are very important to solve such type of problems. Now it is exterior, sometimes it is interior or supplementary, everything. Okay, so we take 125 plus 125 plus x, only three external angles are there or exterior angles are there, is equal to 360. So we add 125 plus 125 is 250 plus x is 360. So x is equal to 360 minus 250 is 110. It is 110. Okay, 110 degree radians. Okay, don't forget to write the answer and units. Okay, in this case degree radians or only degree. Okay, thank you, good luck. Find x in the following figure. Now always copy the figure, rough sketch of the figure from question paper on the answer sheet or in the book, and write all the data given in the problem so that it is very easy to solve. This figure will not be in up to the scale but approximately. Okay, now this is 90, this is 60, this is again a right angle, this is 70, and this is x which we have to find out. So all the angles given are exterior angles of a polygon, or in this case is a particular case of pentagon, and all the angles are in radian, degree radian. Okay, so as we are dealing with exterior angles, we have to apply that property. Okay, so what is the property? Property says that, see, it is written there, that the sum of the measures of exterior angles of any polygon is 360. Okay, remember this property properly. Okay, you have to by this property. Actually, if you solve sufficient numbers of problems, you need not by it, automatically gets by it. Okay, the sum of the, see, I am writing it there, the sum of the exterior angles of polygon or pentagon is 360. Okay, then it is very easy now. See, this is 90 and that right angle is also 90. Okay, right, then 90 plus 60 plus 90 plus 70 plus x, everything is 360. Okay, then add is very simple arithmetic calculation. They are supposed to be very simple. Okay, you can have split them into two, this and this, so that you will not make any mistake. Only thing is you are increasing one step, doesn't matter much. Okay, so we will get it, I think it is 210 plus x equal to 360. It is 310. Okay, so x is equal to 360 minus 310 is 50 degree. Okay, so do write this last step and write units. Okay, so this is over. Always tackle like this. Okay, thank you. So we try to solve some exercises. Now exercise 1 is, see, read this exercise very carefully. You need to read all the maths exercise very carefully. Try to understand the meaning behind it, data given, and solve. Okay, now we read it. Is it possible to have a regular polygon? remember, is talking about a regular polygon. Okay, you know what is regular polygon? Is it possible to have a regular polygon with a measure of each exterior angle? Okay, measure of each exterior angle as 22-degree radian. Okay, 22-degree means if you have a regular polygon, can this regular polygon can have a exterior angle 22? That is what is asked. Okay, and next part is, can it be an interior angle? That means, can a regular polygon have an interior angle as 22? That is what it means. Okay, it is possible or not possible, it's asking reason why. Okay, solution. Answer: we have to focus on the exterior angle measurement and the sides of a regular polygon. Okay, regular polygon, as you know, is a polygon where all sides and all angles are equal. Okay, so relation between the exterior angle and number of sides of a regular polygon, remember this word, a regular polygon, okay, is, let us complete, let us be in synchronized with the writing, is, that is measure of external angle is equal to 360 divided by n, where n is number of sides. Okay, so that you can find whatever question asked. Okay, so we will see, if the exterior angle is 22, that means n will be 360 divided by 22, and that has to be a whole number, but that is not that, that is a fraction. Okay, and you cannot have fraction in a regular polygon like this. Okay, so this cannot be the exterior angle of a regular polygon. Okay, that is one. And another is, we are talking about the interior angle of the polygon is 22. Then, okay, let us complete this first and then we will go ahead. Okay, what it says? It says, if 22 radians is an interior angle, remember we are talking about the interior angle now, this time, of a regular polygon. Okay, then what will be the exterior angle? Exterior angle will be 180 minus 22, that is, I think it is 158. Okay, because we have a formula related to the exterior angle of a regular polygon. Okay, that means if you substitute this value in the above equation 360 upon 158, that has to be any number or the whole number but not fraction, but that is not correct, it is 2.28. that means this also cannot happen. Okay, so hence not possible. Okay, 22 internal angle is also not possible. Next exercise, exercise number 2. Read this exercise or any problem in maths very carefully. Try to understand it. See what data is given and what is asked and what property or what formula is to be used. Always try to see this. Okay. have practice of thinking on the problem. Okay. Now we read it. I'm reading it very slowly. What is the minimum interior angle? See, asking about the minimum interior angle. Minimum interior angle possible for a regular polygon. Try to understand this in your mind. Okay. So what is the minimum interior angle possible for a regular polygon and why? Okay. You have to specify a reason, reason also. And the next part is what is the maximum exterior angle? Okay. What is the maximum exterior angle possible for a regular polygon? Okay. Okay. Try to understand this and go for the solution. Okay. After reading the question properly, that is talking about a minimum interior angle. Okay. We have a relation between sides and exterior angle. So we will use the property where what is the minimum requirement of sides, the number of sides required for a polygon is, see, it is written here, there are three minimum sides possible for a regular polygon. Okay, at least three we need and minimum three we need. Okay, since we will draw a diagram so that problem becomes very easy. We have drawn these three and he's talking about the interior angle. So we will write this all, if that is a figure then interior angle will be 60, 60 and 60. And talking about what is the minimum interior angle possible for regular polygon, of course 60. All these are in radian, don't forget to write the units. Hence we see we could have drawn it by a by a formula, but that formula is for externals. We will see it and we will use it for the next part of this problem. Okay, presently we will see that we can have a minimum 60-degree as an interior angle of a regular polygon. So remember these words, interior and regular polygon. Okay, now for exterior angle, okay, we could have solved it in another way. We will see this exterior angle is 360 upon 3 by formula is 120. Okay, so this, see that angle which is 120. Maximum angle is 120. We are talking about a maximum angle for this. Okay, or we could have got it 180 minus 60. Okay, that could also be done. Okay. So see, this is the angle. Okay, so you have to understand this first properly and then problem is very easy. Okay, we will move ahead to the next problem. Thank you. This is Dr. Bharat Parab helping you in your studies. If you face any difficulty in this topic, write to me in the comment section and I will definitely attend it. Thank you. Good luck.